This video is on stoichiometry. I'm going to kind of try to piggyback this video off of Tyler DeWitt's video about mole ratios. So the first problem that we're going to do is a sample problem from the textbook I'm using, which is sample problem 9.4, and it's from grams to grams, which, you know, Tyler DeWitt just went over moles to moles in his previous video. Okay, so I want to show you what we need to do to get from grams to grams. These coefficients that are there are not gram ratios. They're mole ratios. There's an invisible 1 here. There's an invisible 1 here, right? So, you know, those are 1s. They're not 0s. Okay, so we know that like 1 mole of nitrogen will react with 1 mole of oxygen to produce 2 moles of nitrogen monoxide. Okay, so I'm going to show you how to do this in 2 ways. The recipe way that Tyler DeWitt recommends, and then also in the conventional dimensional analysis way that most textbooks recommend, and your teacher probably wants you to do. Let's start with this. How many grams of NO can be produced when 12.5 grams of O2 reacts? So the very first thing we need to do is we need to take 12.5 grams of O2. Okay, and we need to convert that to moles because these are mole ratios. That's really important to remember. Mole ratios. Okay, so 12.5 grams of O2. Now we know that there's 2 oxygens in every O2, right? So we need to put the molar mass of oxygen. This is 1 mole of O2 is equal to 32.00 grams of O2. And that's because each one on the periodic table is 16.00 or 15.9998 or something like that. But it's 32.00 if we're going one more significant figure than the 12.5. Okay, so when we do this, we figure out that we get 0.3766 moles of O2. So now 0.3766 moles of O2 is what we're going to start with. So we know that we have N2 plus O2 goes to 2NO. Okay, so this is a 1, right? And we're going to end with 0.3766 moles. So we need to multiply the 1 here, the invisible 1, by 0.3766. We would do the same thing here if we were interested in N2, 0.3766. We would multiply that. This is our multiplier. And then this 2 over here, the 2NO, we're going to multiply this by 0.3766. And when I multiply that, I get 0.7352 moles of NO. Okay, this is O2 and this is NO. Okay, so the answer here is going to be 0.7352 moles of NO are produced, but the question asks us for grams. So the question is now, how do we get moles into grams? Well, you know how to get moles into grams. You've done this before. So we do 0.7352 moles of NO, okay? And we're going to use the molar mass. Now, I'm going to write the molar mass over here. An N on the periodic table is 14.01, and an O is 16.00. So when I add those up, I get 30.01 grams. And that equals 1 mole, right, of NO. That's the molar mass. That's what molar mass means. So I want to put the 1 mole on the bottom where it will cancel out here. 1 mole of NO is equal to 30.01 grams of NO. Okay? And so when I do this calculation, I get 22.6, oh, that doesn't look like a 2, grams of nitrogen monoxide. And that's my answer, 22.6 grams of NO. And we did this using the recipe method that Tyler DeWitt has, recommended in his mole to mole ratio video. Okay, so Now I'm going to show you the same problem, except that we're going to do it like we would do a regular dimensional analysis problem using conversion factors. Okay, so I'm going to erase all this, and we're going to start over and do the same problem. We're going to remember that our answer was 22.6 grams of NO. Okay? All right, so we're going to do the same problem. We're going to start with our 12.5 grams of O2. Okay? And we're going to use the molar mass just like we did the last time. We're going to say 32.00 grams of O2 is equal to 1 mole of O2. And then we're going to keep going. Okay, so this is the difference between this method and the last method. Grams of O2 is going to cancel out here. We have grams of O2 in both. Now we have moles of O2, but we're looking for grams of NO. So we know the mole ratio. 1 mole of O2 is equal to 2 moles of NO in this equation only. And where did I get those numbers? I got them from here. There's an invisible 1 right there, and this is a 2 right there. Okay, and so that's where this comes from, and this is where that comes from. Okay, so this is going to cancel out my moles of O2. Now I'm left with moles of NO, but it asks me again how many grams of NO. So now I need to convert using the molar mass. And just like we did before, we're going to use the molar mass. So in the previous example, we calculated the molar mass of NO to be 30.01 grams of NO, okay, to 1 mole of NO. Now, one thing that I see all the time as a mistake on these kind of problems is that people go, oh, well, there's 30.01 grams because that's the molar mass, but I got to put a 2 here instead of a 1 because there's a 2 there. But that's not where the 2 goes. The 2 is only in this particular thing. You can only use these in your mole to mole ratio. Okay? Mole to mole ratio. You cannot use those coefficients when you're dealing with molar mass. It is always 1 mole in molar mass. 1 mole of O2 is 32.00 grams. 1 mole of NO is always 30.01 grams. Okay, so now we have the moles of NO cancel out. All our units are canceled out here except for our grams of nitrogen monoxide, and that's what we're looking for, grams of nitrogen monoxide. Okay, so what I'm going to do here is since I've canceled out all the units, I'm just going to put the numbers in. I have 12.5 times 1 divided by 32.00 times 2, over 1 times, that's a times, 30.01 over 1. Okay, I'm left with grams of NO, so that's what my answer is going to be in. Those are the units that I'm left with. All the other units canceled out. And when I do this, you're going to find that we still get 22.6 grams of nitrogen monoxide. And that is our final answer. The reason we keep 3 sig figs, do you know? Because we started with 3 sig figs here. Okay? So we end with 3 sig figs. Now, you will notice that during the problem, I've used 4 sig figs in my molar masses. That's important. You need to always keep your molar masses more sig figs than the number that you really want to end up with. You don't want to just round to 3 sig figs every step of the way because you're going to end up with like a rounded wrong answer. Okay, so make sure that you keep maybe 4, maybe even 5 sig figs in your molar mass. And then when you end up at the very end, you can round to the right number of significant figures and you'll end up with the right answer. So no matter which way we did this, using the recipe method or using the conversion factor method, we still got the same answer. Okay, so either way is fine. You just need to know what you're doing with each one. Okay, so let's go to the next example and we'll do it again both ways. Okay. All right, this example says, when acetylene burns in oxygen, high temperatures are produced that are used for welding metals. Acetylene is a really fun gas, by the way. You can actually produce acetylene in a balloon and then set it on fire. It's awesome. But anyway, I digress. How many grams of CO2, this is what we're looking for, grams of CO2 are produced when 54.6 grams of C2H2 is burned? Okay, so the very first thing that we notice is that we have grams to grams. These coefficients are very important, but they are moles to moles. So we need to go like through the mole tunnel to get there. Okay, so we need to first convert 54.6 grams of C2H2 into moles. So how do we do that? We need the molar mass. Okay, so I'm going to do the molar mass over here. We have C, which is 12.01, and we have two of those. Okay, so that's 24.02. We have H, okay, 1.008 times 2 is going to be 2.016. When I add them up, I get 26.04. So we put it here, 26.04 grams of C2H2 is equal to 1 mole of C2H2. Okay, so our moles, we're going to get 2.0968 moles of C2H2. Now, wow, I kept a lot of sig figs. That's 5 sig figs. Okay, now remember, I told you, when you're doing this, you want to keep more sig figs than you need to end up with. We only have 3 sig figs here, okay? So we need to, throughout the problem, because we're not ending yet, we want to keep at least 4, maybe even 5 sig figs as we go, okay? So 2.0968 moles of C2H2. So let's write our equation out again. C2H2 plus 5O2, and that goes to 4 carbon dioxide plus 2 waters, okay? And these are mole ratios. So we know here we have 2.0968 moles. Now, how am I going to get from 2 to 2.0968? Okay, what I need to do is I need to divide. 2.0968 divided by 2, and that's going to give me my multiplier. So that is 1.0484. Now I'm going to multiply everything times 1.0484, just like we would in a recipe. What we're interested in here is grams of CO2. So let's concentrate on the CO2. So we'll do times 1.0484 here. This is a 0, it doesn't look like it. And we get 4 times 1.0484. We get 4.1935 moles of CO2. Okay, so that's our answer, except it's in moles. We need grams. Okay, so let's convert that to grams. 4.1935 moles of CO2 times, now if we add up our C and 2 O's, okay, we're going to get 44.01 grams of CO2 per 1 mole of CO2. Okay, and when we get that answer, we're going to do 185 grams of carbon dioxide. Now, this is 3 sig figs. Remember, 3 sig figs, 3. Because we started with 3 sig figs. Okay, so 185 grams. This is our answer. 185 grams of CO2. Now, let's do it the other way with the conversion factors so that you can remember how to do both ways. This way is fine. It's just a lot of writing and there's a lot going on here. Instead, you can do it all in one step using conversion factors. And if that makes sense to you, then go ahead and use that way. If this makes sense to you, then go ahead and do it this way. It doesn't really matter. Just make sure that whatever you're doing, whichever way you're doing it, it makes sense to you every step of the way. Because once it stops making sense, then it's probably wrong. Okay, so I'm going to erase all this. So let's start with 54.6 grams of C2H2. We're going to do our whole dimensional analysis, conversion factor, label method, whatever you want to call it. So we have 26.04 grams of C2H2, okay, to 1 mole of C2H2. Now again, I see people all the time going, oh, but there's a 2 here. No, that 2 doesn't go here. The 26.04 grams is only for 1 mole. You calculated the molar mass. The molar mass is equal to 1 mole. Okay? So now we need a ratio between the moles of C2H2, which we're left with, and the moles of whatever we're looking for, which is CO2. Okay? So this is where these things come into play. We got 2 moles of C2H2 right here. Okay? That comes from here. And we have 4 moles of CO2 on the top. Okay, that is our mole ratio. Now our moles of C2H2 have canceled. Okay, now we're left with moles of CO2. We need to get rid of the moles and get to grams because that's what we need to do. So we multiply that by our 44.01 grams of CO2 per 1 mole of CO2. And we end up with 185 grams of CO2. Okay, so this is a lot less writing, a whole lot less, calculation than the last thing, but you're actually doing the same exact thing with the numbers. That's how you end up with the same exact answer. So just pick whichever way works for you. Okay? I mean, it doesn't really matter. Okay, next example. Okay, the fuel heptane is designated as the 0 point in the octane rating of gasoline. Alright, I mean, interesting to know. Heptane is an undesirable compound in gasoline because it burns rapidly and causes engine knocking. I don't know how many of you remember engine knocking, but when I started driving, if you got like the wrong kind of gasoline, your engine would constantly be like, knock, 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 like there's somebody at the door. So I don't know if that really happens nowadays because our octane ratings are so high that we don't really get a lot of heptane in there anymore. But that's okay. So it's asking us a question about heptane. Okay, how many grams of oxygen are required to react with 22.5 grams of our heptane? Okay, so again, it's grams to grams, but we only have moles to moles in here. So let's convert. I'm going to convert over here. C7H16. Okay. Now, if I add up 7 C's and 16 H's, I get 1 mole of C7H16 is equal to 100.2 grams of heptane. Okay. Now, when I calculate the moles, I get 0.22455 moles of C7H16. Okay, this is moles. Okay, this is a 5. All right, so we're going to go down here. Now, this is an invisible 1. Remember that, okay? So our ending thing is going to be 0.22455 moles. Okay, so our multiplier, we're just multiplying by 1. It's 0.22455 divided by 1, right? So it's the same. 22455. Okay, now, how many grams of oxygen? So we're looking for the oxygen here, okay? I'm moving this over because I kind of ran out of room. We're going to still use the same multiplier times 0.022455, okay? And when we multiply that times this 11, we get 2.470 moles. Okay, that's O2. But we're asked for grams of O2, so now we have to convert our moles into grams. So when you convert moles into grams, we're going to multiply this by the 32.00 grams of O2 in 1 mole of O2, and we get 79.0 grams of oxygen. Okay? 79.0 grams is what our answer is. Let's write that up here, 79.0 grams of O2, so that we remember. And now I'm going to show you the other way with the full dimensional analysis. Okay, so here's what we're going to start with. 22.5 grams of our C7H16. First, we use the molar mass to get into moles. So that was 100.2 grams of C7H16. Oh, that does not look like a 16. Okay, per 1 mole, okay, of C7H16. Okay, now, our grams of C7H16 have canceled out. We have moles of C7H16. So now I need to use a mole-to-mole ratio to get from our moles of C7H16, right? So moles of C7H16 is going to go on the bottom so that it can cancel out with this guy. And what we want is grams of O2, so we're going to put moles of O2 on the top. We never can go directly from moles of one into grams of the other. Now, what do we need here? We need our 11 here and our 1 there. Okay, so it's an 11-to-1 ratio. Okay, so now we just need to go back into grams of O2 because our moles of C7H16 have canceled out. So 32.00 grams of oxygen is equal to 1 mole of oxygen. Now our moles of oxygen have canceled out. And I'm left with 79.0 grams of O2. Okay, so we get the same answer either way. Okay. Next problem. All right, so this one is the same equation that we just had. We're calculating the grams of C7H16, that's our heptene, that are needed to produce 15 grams of water. Okay, so the very first way we're going to do it is using the recipe method that Tyler DeWitt uses. Okay, so we need the molar mass of water. So 15.0 grams of H2O. Now, if we add 2 H's and 1 O, we're going to get 18.02 grams of water. Okay, and that is going to be equal to 1 mole of water. Now, remember, it's always 1 mole for the molar mass. Okay, so when we do this, we get 0.83241 moles of water. Okay, now, moles of water, we have 5 sig figs here. That's a lot. We only have 3 sig figs to start with, but it's okay. Remember, we need to keep more during the problem than we need to end up with, okay? So we know that we're ending here with 0.83241 moles. Okay? So what am I going to multiply 8 times something to get 0.83241? I need to divide, right? So when I divide that, I get 0.104051. That's our multiplier for the whole problem, okay? So I want to multiply every single one of these times that. But really, I'm only interested in C7H16 right now. Okay, that's our heptene. So I'm going to multiply that times 0.104051. And of course, when I do that, I'm going to get 0.104051 moles. Because I'm multiplying it by 1. You see the 1 there, right? 1 times that is going to be that. And now that's moles of heptene. So that's the answer, except it wants grams of heptene. So we need to convert that to grams. So we're going to do the same way, 0.104051 moles of our C7H16. And in the previous problem, we calculated that molar mass to be 100.2. So 100.2 grams of C7H16 goes up here, okay? And 1 mole of C7H16 goes here, okay? And when we multiply that out, we get 10.4 grams of heptene. Okay, so there's 10.4 grams. Let's write that up here, 10.4 grams of C7H16, just so we remember what we got the first way. All right, we're starting with 15.0 grams of water. We first use the molar mass to get to moles of water, so we need to put our grams of water on the bottom. Okay, so we have 18.02 18.02 was our molar mass of water, is equal to 1 mole of H2O. Now people will say, oh, but it says 8. Nope. The molar mass is equal to 1 mole. Okay? Now we need our mole to mole ratio. So we've gotten rid of our grams here. Okay, so now I know I need to put moles of water on the bottom, and I'm trying to get to C7H16. So I know I'm going to put moles of C7H16 here. Now I use the mole to mole ratio. The 8 goes down here, and this invisible 1 from over here goes there. Okay? Now, my moles of H2O have canceled. Now I have moles of C7H16. I need grams of C7H16. So again, I use my molar mass, which is 100.2 grams of C7H16 per 1 mole C7H16. And as you can see, my moles cancel out. I'm left with just grams, and I end up with 10.4 grams of our C7H16, which is heptane. Okay, so I hope this little video was informative for you. Thank you so much for watching all the way to the end.